structured pulse of light, then silence. A signal no comet should produce recorded 7 days after perihelion, as 3i Atlas drifted through the sun's glare with a brightness surge no thermal model can explain. And you traveller are here now for a reason drawn by the quiet pull of something the cosmos is trying to show you. What are the odds that an object flaring with carbon dimer and ammonia yet shedding no dust at all is simply following instinct and not intention? What if this brightening is not decay but response? Stay a while. Let's drift through the silence together. The instruments continued to study the strange calm that followed perihelion, tracing the faint emissions drifting from 3i Atlas like the breath of a world older than sunlight. Spectrometers showed the brightness rising in quiet defiance of every model, as if the object held its own rhythm beneath the heat of the star it had just survived. Cyanogen, hydroxyl, and water vapour moved outward in thin, glowing layers, forming a halo too smooth to belong to ordinary ice. It was gas without dust, a silence without debris, a reminder that not all stories of light begin with rupture. Tonight, the universe whispers again. Polarimetric readings joined the puzzle, revealing a coma so clean it scattered almost none of the expected particulate light. Researchers spoke softly in their late-night rooms, marvelling that the glow came from molecules fluorescing cold rather than fragments reflecting heat. The mathematics felt delicate, almost meditative emissions, rising dust absent symmetry, holding where chaos should rule. And in that symmetry a question lingered how something forged under alien stars could behave with a kind of graceful restraint. It's all right to not know. Thermal simulations added their quiet contradiction. The surface should have warmed only enough to release carbon monoxide and carbon dioxide, yet water vapour surged as if the interior had been waiting for the sun to touch it. Models tried to capture the temperature curves, their digital traces bending like threads of thought through darkness, but none matched the measured calm of the real event. Traveller. The object seemed to answer the star in its own language, not through violence, but through slow awakening. Tonight the stars will keep their silence. Scientists proposed that cosmic rays had spent millennia hardening the shell, compressing organics into a dark crust while sealing volatiles deep within. When sunlight finally reached those pockets, the release came not as rupture but as steady breath, a controlled shift rather than an outburst. Observatories described the transition with reverence, noting how the light curve rose gently, a smooth plateau of luminosity that held as though guided by some internal patience. Somewhere beyond our reach, something ancient still moves. The chronographs aboard Soho drew a brighter portrait. Time-lapse sequences revealed an asymmetric glow stretching behind 3i Atlas, long and narrow, almost a filament drifting through the sunlit sea. Natural comets paint their tails wide like brushstrokes, but this one held its shape with quiet discipline. Observers compared the plume to a whispered line of light, thin enough to feel intentional yet too subtle for any firm conclusion. You're not lost in space, you're part of it. Solar Orbiter added a layer of stillness to the mystery. Its plasma instruments registered fluctuations that seemed too coherent for random, outgassing small waves forming and fading, as if the object's breath met the solar wind with a measured pulse. No alarms, no conclusions, only the soft acknowledgement that some interactions in the heliosphere behave more like ceremony than accident. It's all right to not know. Even when speculation arose, it arrived gently. Reviewers noted that the plume resembled directive venting more than chaotic release, though mainstream voices insisted the word directed need not imply purpose. In the quiet halls of research centres, scientists spoke of collimated gas magnetic shaping and layered sublimation, each term a calm attempt to understand an object that refused to rush its story. Silence is the language of distant worlds. 3 competing models emerged, none complete, none dismissed. One invoked the build-up of subsurface pressure breaching a hardened crust. Another described alternating layers of ice sublimating as sunlight seeped deeper. A third proposed that solar radiation charged the surface, triggering slow plasma erosion rather than heat-driven release. All 3 captured pieces of truth, yet none found the full arc. Every explanation felt like a soft outline traced around an object too quiet to reveal its true edges, the gas only brightening remained the heart of the enigma. Dustless Comet are rare but not unknown. Still nothing in recorded astronomy approached this level of purity. Instruments searched for scattered light for grains stirred loose by the escape of vapour, but found almost none. Instead, the gases moved outward like a calm mist reflecting the star without carrying the usual burden of debris. Tonight, the universe whispers again. As days passed, telescopes around the world continued to track the glow. Its shape held, its brightness lingered, and its silence endured. Some observatories described the coma as an invisible envelope, a thin sphere where gas drifted without turbulence, almost serene. This was not the chaos of melting ice. It was structure without rigidity, order without command. Listener, in moments like these, astronomy becomes a kind of meditation. Subaru confirmed the same composition seen earlier, water vapor, carbon compounds, ammonia, yet still found no scattered dust. Hubble's images echoed the same truth, their faint, ultraviolet tracings showing gas escaping cold, rather than heated to violence. For scientists accustomed to comets shedding grains like sparks, the absence felt like standing in snow that refuses to fall. Tonight the stars will keep their silence. Then came the mid-infrared readings from JWST. They revealed signatures of hydrocarbons long shaped by radiation, compacted into a crust that allowed gas to seep through microscopic pores, while holding solid particles fast. It was as though the object had aged into resilience, its outer shell transformed into a guardian that released only breath, never bone. In that quiet discipline, astronomers found a strange comfort, a reminder that endurance can be a form of grace. Laboratories proposed that cosmic radiation had sculpted the crust into something almost ceremonial. Tholin-rich layers dense enough to resist cracking coated the nucleus, like a memory preserved, through eons of wandering. Beneath them, ancient ices waited in stillness until the star's warmth finally reached their sealed chambers. When they opened, they did so gently, allowing gases to escape without stirring dust. Somewhere beyond our reach, something ancient still moves. Other theories suggested origins shaped under unfamiliar stars, red dwarf shadows, low-temperature birthplaces, different elemental ratios. The chemistry hinted at stories older than the sun carried now across our sky, with a patience that outlived planets. Scientists noted that isotopic signatures differed subtly from local comets. The variations were small, but enough to remind the field that not all wanderers speak the same atomic dialect. It's all right to not know. Even the difficulty of measurement became part of the meditation. Without dust-like curves told only half the tale, forcing astronomers to read the fluctuations of gas alone. Rotation had to be inferred from molecules drifting into and out of view, a soft oscillation of brightness repeating like a heartbeat under starlight. Traveller the Cosmos remembers, when Solar Orbiter detected a faint magnetic ripple, the quiet deepened. Ionized gas seemed to interact with the solar wind in a narrow stream rather than a wide one, a subtle channel of charged particles shaped by the object's orientation. Plasma tails are usually wild, but here the motion felt restrained, as though the universe itself had chosen brevity over spectacle. Tonight the universe whispers again. And through all of this data-doubt-layered interpretations, the object remained calm. It drifted outward, still glowing, still shedding vapour, still refusing to scatter the dust astronomers expected. Each observation carried the same conclusion, spoken with soft acceptance. The phenomenon is real, and the phenomenon is rare. The rest is silence. Sleep now, traveller. The cosmos will hold the questions until morning. Spectrometers continued to trace the gentle emissions drifting from 3I Atlas molecules glowing softly in the sunlit vacuum. Cyanogen and hydroxyl rose like pale threads, forming a halo too smooth for ordinary ice. Even after perihelion, the object brightened, as if awakening rather than breaking the light curve, unfolding with patience instead of force. Gas without dust, glow without fragments, a reminder that not all stories of heat are born from rupture. Polarimetric readings added their quiet truth. The coma scattered almost no particulate light, behaving more like vapour than debris. Researchers spoke quietly in their late-night rooms, noting how fluorescence replaced reflection, how the object's brightness seemed shaped by chemistry rather than chaos. These measurements felt less like anomalies and more like gentle corrections to assumptions long held about comets. Some nights science breathes differently. Thermal models offered another soft contradiction. Temperatures should have released carbon monoxide or carbon dioxide, yet water vapour appeared in abundance, as though deeper layers had been waiting for the sun to touch them. Simulations bent themselves around this possibility, tracing curves that never quite matched the stillness of the real data. The object answered heat in its own rhythm, a rhythm that needed no urgency to be understood. Some astronomers suggested that millennia of cosmic rays had hardened the crust-sealing volatile ices beneath an organic layer. When the sun warmed those inner chambers, gases rose not in bursts, but in steady release, a slow unwinding of pressure stored across ages. The light curve supported this idea: no sharp spikes, no violent drop, only a calm rise to brightness that held its shape like a breath released with intention. Chronograph images revealed a narrow glow stretching behind the object, long and faint, almost filament like in the bright field near the sun. Unlike ordinary comets whose tails bloom wide into space, this plume held a thin, deliberate profile. Its persistence suggested structure, but not necessarily purpose, only a kind of quiet coherence that nature sometimes draws without meaning to. There was beauty in its restraint. Solar Orbiter provided a second perspective. Its plasma detectors sensed fluctuations in the solar wind small waves that seemed to follow the object's rotation. The pulses did not resemble instability, but rather a measured interaction, ionized molecules meeting sunlight and magnetic fields, with a rhythm too soft to call deliberate yet too consistent to ignore. In that steadiness, the phenomenon felt almost ceremonial. Dust should have appeared by then. It did not. Subaru confirmed the same composition seen earlier: water vapour, faint organics, carbon compounds. But the familiar hazy scattering remained absent. Hubble's ultraviolet tracings echoed this truth, showing gas expanding cold, as though the object preferred to keep its solid pieces close. Some comets flare with dust. This one exhaled only light. Mid-infrared data from James Webb deepened the quiet. It revealed hydrocarbons shaped by ages of radiation compacted into a dark crust that let gas seep outward through tiny pores while holding solid grains within. The surface behaved like an ancient seal, releasing vapour, gently never spilling dust into the void. This was resilience, sculpted by time, not fragility reacting to heat. Laboratory experiments suggested how such a crust could form. Cosmic radiation striking ice-rich and carbon compounds can create dense tar-like tholin layers, each cycle thickening the shell. Over millions of years, those layers might become strong enough to withstand sudden warming, flexing rather than breaking. If so, the object carried not just chemistry, but endurance survival written into its very crust. Other interpretations touched on origin. Some noted that red dwarf systems form objects with unusual elemental ratios, low silica content, or volatile, rich cores. If 3I Atlas was born under such conditions, its dustless nature would not be a mystery but an inheritance. The isotopic hints pointed gently in that direction, subtle deviations that suggested a birthplace colder than any region within our solar system. Even the difficulty of measurement became part of the meditation. With no dust to track, astronomers studied brightness oscillations in gas, alone looking for rotation in small drifting changes. The pattern held near 8, 6 hours of soft rhythm repeating like a distant heartbeat. Listener, even in silence motion leaves a trace. Then a faint magnetic ripple appeared in Solar Orbiter's data, nothing sharp, nothing violent, only a gentle wave trailing the object's path. Ionized gas seemed to interact with the solar wind in a narrow channel, shaping a plasma wake unusual for a body this small. Such behaviour did not break the laws of physics, it merely nudged them into a quieter expression. And through it all, the 3I Atlas continued outward, still glowing, still exhaling thin vapour, still rejecting the dust that comets so readily surrender. Each measurement ended with the same soft acceptance of phenomenon both natural and rare. The universe does not always reveal its reasons, and it does not have to. Tonight the stars will keep their silence. The days after Perihelion unfolded with a kind of measured quiet, Instruments scanning 3i Atlas found that its brightness did not fade as expected, but held steady as if the object were adjusting rather than cooling. Water vapour lines rose sharply, nearly 40 times above their earlier levels, yet temperatures in the coma remained low. It was a paradox spoken in molecules cold gas moving with the grace of heat. In science, some contradictions arrive not to trouble us but to slow our breath. Observatories across 3 continents confirmed the surge. Hydrogen lines widened, hydroxyl bands deepened. Nothing about the trend resembled the sharp flare of an explosion. Instead, the data looked like unfolding a slow unlocking of buried layers, responding to sunlight for the first time in ages. The absence of dust persisted, anchoring the mystery gently rather than escalating it. The cosmos has its own pace for revelation. To understand the quiet intensity of the realist, researchers looked to buried volatile reservoirs, chambers sealed under the crust where ice had waited in darkness for millions of years. If the surface fractured even by a hairline, sunlight could reach these hidden pockets, awakening the old materials with serene inevitability. James Webb's spectrograph supported this idea, tracing rotational bands of water and carbon dioxide from deep within untouched until that moment. Silence is the language of distant worlds. Yet one detail softened every conclusion: the rate of vapour release exceeded what solar energy alone could support. It was as though another source of warmth lived inside, not hot but steady, like pressure shifting through crystalline layers. Some proposed chemical reactions, subtle oxidation chains triggered as fresh ice met the star's light. Others described the possibility of structural collapse where cavities opened one by one, letting gas escape in long measured breaths. Each idea rested not in urgency, but in acceptance that nature is rarely simple. Even the shape of the light curve felt unhurried. Instead of peaks and fractures, it held a gentle slope, rising with the patience of erosion and settling with calm precision. When Hubble mapped the coma, it found the sphere expanding evenly, a faint ghost, nearly 50,000 kilometers wide, its density smooth, its glow unbroken. Scientists spoke softly about equilibrium, how even disrupted systems can find stillness when given space to settle. Parker Solar Probe soon detected the outer effect, small increases in hydrogen density drifting through the solar wind. These signals, faint but sincere, hinted at how an object less than a kilometre wide could imprint itself briefly on the environment around it. It wasn't force, it was presence. A small piece of the galaxy breathing in the light of a new star. Attention turned to the structure of the interior. Webb's deep reading suggested multiple zones and irradiated crust, a transitional layer of mixed ice and mineral, and beneath that something pristine. Crystalline water embedded with ammonia and methane, a signature cold enough to belong to the interstellar clouds where stars are born. Within this layered architecture, scientists saw an echo of time, as though the object carried the memory of its first formation. The thick crust appeared essential to its survival. Radiation hardening had forged a shell strong enough to withstand perihelion without fragmenting. Some mineral fibres may have grown through the outer layers, strengthening them the way thread strengthen woven cloth. Experiments on Earth hinted that such materials can endure stress with surprising resilience. In the quiet spaces of their labs, researchers found themselves admiring, not fearing the object's strange composure. Temperature readings brought another whisper of complexity. Even after the surge, the core remained colder than expected, suggesting delayed heat flow, or internal reactions, maintaining small steady pockets of warmth. Neither explanation disrupted the serenity of the data. Instead, they revealed a system finding balance within itself, adjusting to the sun like a living archive. Listener, what emerges from darkness does not always rush to meet the light. Subtle oscillations in brightness hinted at her internal layering. Some saw them as acoustic echoes, tiny shifts travelling through the crust like soft taps on ancient stone. Others suggested density contrast shaped by eons of radiation. No single interpretation dominated. Instead, the field welcomed uncertainty as a companion, a place for curiosity to rest without demand. Chemists noted that the outer shell's composition resembled material capable of shaping prebiotic molecules under the right conditions. If such fragments pass between star systems with regularity, then the ingredients for life may drift far more freely than imagined. A particle released here might seed chemistry elsewhere, a quiet continuity carried by travellers of ice and dust. As November advanced, the object continued to fade, though slowly. JWST still captured whispers of its glow, each spectrum a deeper look into material untouched by sunlight until this year. Time was running short, but urgency did not enter the work. Science at its best honours the pace of the cosmos rather than rushing to match it. Researchers describe the moment as studying a world in miniature, a geological story less than a kilometre wide, yet layered with the history of a galaxy. When they spoke of the crust, they spoke of endurance. When they spoke of the core, they spoke of origins. Every reading deepened the sense that 3I Atlas was more than ice and mineral, it was time made visible. In the quiet of their observatories, many found themselves contemplating what it means to witness such material at all. Most interstellar objects pass unseen. This one paused long enough for us to listen. Its flare, its stillness, its breath of ancient vapour, none of it demanded interpretation. It simply existed, revealing itself in small, patient increments, like a story told without hurry. And as the coma thinned and the glow diminished, astronomers accepted what all observers must accept, that some truths arrive gently and some remain just beyond reach. Tonight, the stars will keep their silence. As 3I Atlas moved farther from the Sun, the elongated plume it left behind remained one of the quietest wonders in the data stream. Solar observatories watched the filaments stretch across millions of kilometres, thin as a brushstroke and steady as a breath. Instead of dispersing into a chaotic fan, the structure held an improbable coherence, following the object's motion rather than the solar wind. Scientists described it not as a tail, but as a trace and echo of shape carried forward by light itself. Some nights a single line of brightness feels like a philosophy written in silence. Between October 30th and the first days of November, time-lapse imagery captured small shifts within the plume, subtle pulses of intensity repeating in rhythm. Natural jets usually flicker in irregular bursts, yet these patterns rose and fell with a softness that suggested continuity. Still, no one mistook regularity for intention. Nature too finds patterns in its wandering. The plume's persistence became a reminder that not all order begins with design, sometimes it begins with patience. Frame by frame analyses showed an asymmetry that deepened the quiet mystery. One side of the coma brightened while the opposite remained dark, as though sunlight spoke to only one face of the object. That contrast could have been orientation surface chemistry, or some hidden fissure aligned perfectly with the star. Each explanation was offered gently without urgency, because in this observatory lit calm, the goal was not to solve the universe, but to walk beside it. When simulations attempted to reproduce the plume, researchers imagined fractures running lengthwise along the crust. If sunlight warmed a fissure just enough, a jet could emerge like a narrow thread, and as the object rotated parallel, fractures might join their flows into a single elongated glow. The diagrams resembled the anatomy of trees or the branching of frost structures, formed through simple physics made beautiful by time. It is all right to not know. But real space is rarely that tidy. The plume refused to dissipate the way simulations predicted. Even as 3I Atlas drifted away from intense heat, the line of gas held together longer than models allowed. Scientists proposed magnetic shaping ionized particles responding to fields, rather than purely thermal escape. Solar Orbiter's magnetometer supported this, gently detecting faint ripples aligned with the plume's direction. The magnetic pattern was small, but it lingered like the soft ring of a bell long after it is struck. What puzzled observers most was direction. Plasma tails usually extend away from the sun, sculpted by radiation pressure. This one pointed slightly off-axis, leaning instead toward the object's path. It was a deviation measured in degrees, yet meaningful in its defiance. Some suggested the object carried a residual field of memory from its interstellar journey, able to guide charged particles along paths of its own making. Others simply noted that the cosmos often behaves with subtleties beyond our first expectations. Ground-based observatories found an additional detail. The plume shimmered faintly in a narrow band of visible green, only perceptible through sensitive filters. This was not the broad emerald glow of common cometary gases, but a delicate reflection from sparse mineral grains, likely sodium or magnesium riding along the gas flow. Too few to form dust, but enough to tinge the structure with a spectral whisper. In that faint colour, researchers saw a reminder that even the simplest emissions carry stories from the crust they escape. Simulations from Japanese solar physics teams suggested that metallic ions, once energized, could help stabilize a jet by interacting electromagnetically. Such flows, though natural, could create the illusion of deliberateness. A plume held together not by purpose but by the quiet mathematics of charged particles moving through sunlight. Silence is the language of distant worlds. Preprint papers began circulating, offering interpretations written with caution and humility. Some saw the plume as a controlled phase of venting shaped by orientation. Others argued that projection affects our viewing angle may have exaggerated its order. In the community of astronomy, disagreement rarely meant conflict. It meant curiosity still breathing. Night after night, telescopes gathered more light, letting the object tell its story at the pace it preferred. One idea gained gentle traction. The plume was not a sign of violence, but of transition. As sunlight penetrated deeper layers, the crust warmed unevenly, opening vents in a sequence shaped by rotation. Gas escaped through these new channels, merging into a collective stream that looked continuous from afar. A traveller observing from Earth would see a line of light, unaware of the layered processes unfolding in quiet coordination. Then came the pulse. 30 hours after perihelion ultraviolet instruments recorded a rhythm, small fluctuations repeating slightly slower than the rotation period. Not strong enough to imply mechanism, not chaotic enough to dismiss. It resembled a planet's aurora or a star's oscillation, a natural resonance speaking softly through gas. Listener, some rhythms are not messages. They are simply the universe humming to itself. When Solar Orbiter detected a brief secondary plume perpendicular to the first, the geometry deepened. Two faint emissions crossing like threads in a loom, appearing only for a short window before fading. The alignment felt unusual, but not impossible. Orientation, heating, surface texture, all could play quiet roles. Scientists sketched diagrams not to claim answers but to explore possibilities. What surprised the community was how serene the object remained. No fragmentation appeared. No violent jets tore away material. The nucleus glowed softly, rotating with the same measured period as before. For an object that had endured a global thermal shock, its composure bordered on calm. As days passed, the coma stretched and thinned, yet the elongated plume persisted like a memory refusing to scatter. Long after brighter features faded, this thread of gas followed, dimming slowly into the heliosphere. Observatories described it as a wake, not the wake of turbulence but of presence, a trace of passage. And as the plume finally weakened into quiet dispersal, astronomers accepted what the data had been suggesting all along. This was not disorder, nor was it design. It was simply a moment in the life of a wandering fragment shaped by forces older than stars, a phenomenon rare but natural, delicate yet enduring. Tonight the universe whispers again, and the sky keeps its silence. As the elongated plume slowly faded, a new pattern emerged, one quieter but no less profound. Instruments began detecting a rise in water vapour lines, a surge nearly 40-fold compared to pre-perihelion levels. Yet the temperature of the coma remained low, so low that the vapour seemed impossible by conventional heating alone. It was as if the nucleus had found a way to release memory without melting, letting ancient ice turn to breath in the cold. In astronomy, some mysteries arrive not to be solved but to be witnessed. Across the world, observatories confirm the same gentle paradox. Hydrogen lines widened in calm arcs. Hydroxyl emissions held steady, tracing the presence of water without revealing its full journey outward. The rise continued for nearly a week, sustained rather than abrupt, suggesting a process unfolding beneath the surface. Scientists spoke softly of phase transitions, pressure release, and sunlight finding forgotten reservoirs in the dark interior. The data did not shout, it whispered. The concept of a buried reservoir soon took root. Cosmic rays may have shaped a crust dense enough to seal a deeper ocean of ice, preserving it through millions of years of travel. When the perihelion shock fractured that shield, even in microscopic threads, sunlight could slip inside with unexpected depth. The sudden access would not cause an explosion, but a slow, persistent awakening like warmth seeping through winter soil. Silence is the language of distant worlds. James Webb's spectrograph lent support to this quiet unfolding. Its mid-infrared readings showed rotational lines of water, carbon dioxide and other volatiles rising from deeper layers not from the surface. The pattern suggested untouched ice material older than our Sun finally feeling starlight once more. The ratios were so symmetrical that researchers felt less like they were observing destruction and more like witnessing release. That distinction changed everything. Yet one detail troubled even the calmest analysis. The energy absorbed at perihelion could not account for the scale of the outgassing. There had to be another source, chemical, structural or pressure-driven, quietly aiding the transition. Some proposed exothermic reactions igniting when sunlight reached radiation-processed compounds. Others described a cascading collapse of internal cavities, each small opening creating the next like a chain of breaths moving through stone. Listener, even complexity can unfold with grace. As the days passed, a spherical halo formed around the nucleus, expanding to tens of thousands of kilometers. It glowed faintly uniform and serene, free of filaments or turbulence. In the stillness of that sphere, astronomers saw balance gas dispersing evenly despite its ancient confinement. Hubble's ultraviolet images traced the halo's slow growth, each frame showing a calm diffusion that felt more like meditation than motion. Tonight the stars will keep their silence. Meanwhile, Parker Solar Probe detected a subtle rise in hydrogen density near the ecliptic plane. Though not definitively linked to 3I Atlas, the timing aligned in an almost poetic way. It suggested that even a small interstellar traveller could influence the solar wind, however gently, leaving a faint echo in the plasma sea. The disturbance was not forceful. It was a ripple, a soft acknowledgement of presence rather than a disruption. Attention gradually shifted from the coma to the core. Researchers began speaking of interior layering with a kind of reverence. James Webb hinted at 3 major zones, a scorched outer crust darkened by radiation, a transitional region of mixed minerals and volatile ices, and a deep crystalline core formed in the coldest reaches of a molecular cloud. Each layer carried the chemistry of a different era, a different place, a different kind of light. In studying it, scientists were studying time itself. The outer crust appeared crucial to the object's survival. Tests suggested that radiation could polymerize organic compounds, forming a shell resistant to temperature swings. Mixed with micrograins of silicate, this shell could act like armor, flexible, strong, and slow to fracture. Without such a shield, the perihelion shock might have shattered the object completely. Instead, it endured, vented, and settled as though shaped for long journeys between stars. Temperature remained another quiet puzzle. Even as gases escaped, the inner region stayed colder than expected. One explanation involved slow conduction, the sun's heat, still migrating inward through dense material. Another considered chemical warmth rising gently from reactions triggered by new exposure. Neither explanation felt urgent. Both carried the tranquility of processes unfolding at their natural scale. When mysteries evolve slowly, they invite contemplation rather than alarm. Oscillations in the infrared brightness suggested internal structure more complex than the smooth exterior implied. These oscillations were small, almost imperceptible, like faint echoes in a cave. Some scientists speculated they reflected density contrasts or pockets of trapped ice resonating with the object's rotation. Others believed they were artifacts. In the calm of deep space observation, both possibilities could coexist without conflict. The prospect of prebiotic chemistry soon entered the conversation. The crust's nitrogen-rich organics resembled materials known to form amino acid precursors under the right conditions. If bodies like this drift regularly across the galaxy, then the seeds of life may not stay tethered to any one star. They may wander patiently, waiting for worlds to meet them. Traveller, you are not lost in space, you are part of it. By early November, the object's glow softened, but did not vanish. JWST still captured signatures from its fading coma, tracing the exhalations of distant epochs preserved in ice. Each new spectrum felt like the turning of a fragile page in a book that would soon close. Scientists knew the window was short, but they worked without urgency, letting the calm of observation guide them. In the quiet halls of research centres, 3A Atlas was no longer treated as an event, but as a presence, a reminder that interstellar matter is not simply debris, but memory carried across light years. The water surge, the dustless halo, the layered chemistry, all of it formed a portrait of a world, small in size yet vast in history. And as the coma thinned into the solar wind, the object offered one final lesson. Not every revelation arrives with noise. Some arrive like this gentle, patient, unhurried. A moment of cosmic truth drifting outward, disappearing softly into the dark. Tonight, the universe whispers again. When scientists compared 3I Atlas to the interstellar visitors that came before it, a quiet realization began to form. Each object, Oumuamua in 2017, Borisov in 2019, and now Atlas, carried a different kind of presence, like chapters from distant corners of the galaxy. Oumuamua arrived dry tumbling and silent accelerating in a way that left more questions than answers. Borisov, by contrast, appeared bright, and dust-filled, comforting in its comet-like familiarity. Atlas stood between them, neither wholly icy nor wholly inert, its behaviour whispering of origins older than the starlight that revealed it. Some comparisons don't seek conclusions, they seek perspective. Oumuamua's trajectory first suggested its strangeness. It reflected light in sharp, uneven pulses, as though shaped by metal or stone smoothed by time. No coma appeared, no gas, no dust, only a faint non-gravitational acceleration that stirred long nights of debate. Many wondered how something so still could move as if touched by an invisible breeze. Others felt that uncertainty was a reminder that space does not owe us explanations. The cosmos speaks in motions, not in instructions. Borisov felt gentler in contrast. It behaved like comets humans had known for centuries, shedding dust and streaming cyanogen in broad arcs. Yet even it carried secrets. Its dust grains were finer, more uniform and colder than anything found in the solar system. These grains hinted at a birthplace low in turbulence, a nursery far from its star's warmth. It was familiar and foreign at once, a reminder that similarity does not erase difference. Silence is the language of distant worlds. Atlas complicated everything again. It arrived with a crust darkened by time, but a core bright with hidden ices. It vented without dust, glowed without shattering, and responded to sunlight with a strange kind of discipline. In its light curve, scientists saw neither chaos nor design, only a calm persistence, a quiet refusal to behave like anything we had named before. It was not a contradiction, it was a bridge. On comparison, Chart's Atlas sat between its predecessors. Oumuamua dry and reflective, Borisov wet and familiar, Atlas mixed and reactive. Researchers began to see not isolated curiosities but a sequence objects showing different stages of interstellar evolution. Perhaps radiation hardens them, preserving only rock. Perhaps others escaped their home systems, early carrying volatile reservoirs through the void. Atlas, with its layered crust and hidden ices, might represent a middle age of wandering. In science, patterns often begin as whispers. What set Atlas apart was endurance. Oumuamua tumbled through the inner system and vanished quickly, offering only brief glimpses of its nature. Borisov fragmented after Perihelion, its nucleus surrendering to sunlight. Atlas survived its encounter intact, shedding vapor in rhythmic pulses as though releasing a long-held breath. It behaved less like a fragment and more like a system resilient and self-balanced. Some objects arrive fragile, others arrive prepared. Even its chemistry told a story of transition. The volatiles Atlas released stayed cold as they expanded, a sign that heat did not seep inward as easily as expected. This insulation suggested something remarkable, a crust shaped not only by radiation but by structure, perhaps formed from polymers and silicates compressed through cosmic time. When sunlight reached deeper layers, the response was steady, not violent, a slow transformation rather than a collapse. Listener, the universe often chooses gentleness where we expect force. The dustless nature of Atlas also placed it in its own category. Borisov carried generous dust. Oumuamua carried none. Atlas released gas without lifting particles, as though its crust held them close even while letting breath escape. To some, this meant a chemical fingerprint of a birthplace richer in organics and poorer in silicates. To others, it meant a surface sculpted into cohesion by millions of years of cosmic rays. In either case, the silence of dust became part of its signature. When plotted on rotation versus brightness charts, Atlas displayed regular oscillations aligned with its venting pattern. The pulse repeated gently, neither mechanical nor chaotic. Oumuamua's rotation felt like a tumble. Borisov's was hidden beneath its dust. Atlas rotated like a steady metronome carrying its own rhythm into the heliosphere. It did not imitate. It simply moved as it was shaped. Comparative studies soon deepened into a new perspective that interstellar objects may not be remnants, but travellers' reactive bodies shifting chemically as they meet new stars. If so, then Atlas was not alone in its complexity. It was an example of how matter can evolve across light years. The crust grows darker, the core remains bright, the layers record cold eras and warm eras like tree rings of frozen worlds. Not a piece of debris, but a timeline. The term reactive interstellar object appeared quietly in early drafts of papers describing bodies that respond to heat radiation and plasma rather than simply endure them. Such language felt less dramatic than poetic, an attempt to honour what Atlas represented. Some objects drift passively, some change. Atlas changed. Mission designers began discussing what future probes might capture if they intercepted an object like this. What samples could reveal about pre-solar chemistry, about the birthplaces of organics, about the diversity of worlds that never grew large enough to become planets. But these discussions were not urgent. They moved with the same calm as the object itself, aware that centuries would pass before the next visitor matched this level of clarity. In the public imagination, Atlas took on a gentler symbolism. Not a threat, not an omen, but a reminder of how rarely we get to witness material from another star behave in real time. The idea that such matter can glow, shift, breathe, and drift through our sky felt almost like a lullaby written in physics. And as comparisons continued, numbers aligning, graphs rising, chemical ratios overlapping one, understanding settled over the scientific community like dusk. The diversity of interstellar objects is not a complication. It is a gift. Each visitor shows a different path through cosmic time, a different story of exposure pressure and light. Traveller, you're not lost in space, you are part of it. As Atlas faded into deeper darkness, its legacy remained calm and profound. No spectacle, no upheaval, only a new kind of understanding offered softly, carried lightly, and left, to drift in the minds of those who watched. Tonight, the universe whispers again. As Three-Eye Atlas drifted outward, astronomers began to notice a new subtlety, written not in light, but in the solar wind. Instruments aboard the Parker Solar Probe detected a faint drop in proton density, followed by a ripple that moved gently across the magnetic field. It resembled the echo of a coronal event, yet no eruption had occurred. Instead, the disturbance traced backward toward the path of the interstellar visitor, as though its presence alone had reshaped the plasma around it. A day later, a solar orbiter confirmed the same pattern from a different angle. Two independent detections created a quiet symmetry, one that scientists approached with calm curiosity rather than alarm. The magnetic deflection extended far beyond what a small gas-emitting body should produce 10 times the radius expected from its size. Such influence did not signal power, only sensitivity, a delicate interaction between ionized gas and the solar wind flowing past it. Silence often reveals more than noise. The most intriguing detail was rhythm. The magnetic ripples rose and fell every 8 to 9 hours, matching the rotation period inferred from brightness oscillations. With each turn, the object seemed to breathe outward, releasing faint pulses of charged particles into the heliosphere. Astronomers described it not as activity, but as cadence, a natural consequence of venting interacting with sunlight. Even here in the invisible fields around the sun, the object carried its own gentle tempo. Researchers at the Johns Hopkins Applied Physics Laboratory proposed a simple explanation. If the gases escaping from Atlas were ionized, they could briefly form a miniature magnetosphere, a bubble that resisted the solar wind before dissolving. Such bubbles have been observed around comets, though rarely so coordinated. What set Atlas apart was consistency. The pulses returned with the precision of a repeating wave, too soft to suggest mechanism, yet too steady to dismiss as noise. The universe speaks in harmonics. Radio telescopes soon joined the conversation. The Very Large Array detected faint emissions in the kilohertz range synchronized with the magnetic ripples. These were not signals, not messages, merely the natural song of plasma waves oscillating in charged space. Still, the coherence was unusual. Plasma rarely behaves tidally, yet here the waves aligned in gentle order, rising and fading like distant tides. Listener, some patterns exist only to remind us that nature can be elegant. Scientists began referring to Atlas as a plasma resonator, a body small enough to react quickly yet complex enough to guide ionized flow along narrow paths. It was a poetic term for a physical truth. Even a fragment of ancient ice can hum when touched by sunlight. The rhythms did not imply purpose. They implied structure shaped by the crust chemistry and the rotation beneath. The cosmos often creates instruments without intending music. Trajectory analyses soon revealed another whisper of change. Atlas was drifting slightly off its projected path, barely measurable yet consistent. This deviation was not unusual. Comets often experience small adjustments when gases vent unevenly. But Atlas released gas in quiet pulses, not chaotic jets, suggesting a subtle, continuous push aligned with its rotation. Over days, the shift accumulated like a gentle hand guiding a drifting leaf. No drama, only motion. Infrared readings detected hints of deeper erosion within the crust. Silicate vapor appeared in trace amounts, suggesting the object's surface was thinning where sunlight reached. These changes were not destructive. They were transitional, revealing earlier layers forged in colder regions of space. In each new spectrum, scientists saw the past rising softly into the present, a timeline dissolving into vapor under a star it had never expected to meet. Magnetometers recorded the diminishing echoes of the earlier pulses. The signals weakened with distance but stayed in phase, fading like footsteps in fresh snow. Even as it receded, Atlas behaved with the same gentle rhythm, rotating, venting, drifting. The object was no longer active in the dramatic sense. It was quietly alive in the physical one, exchanging energy with its surroundings the way all celestial bodies do when warmed by a star. For mission planners and theorists, these interactions carried profound implications. They suggested that interstellar travellers may not always pass inert through new systems. Some may breathe, however, faintly in response to unfamiliar light. Others may carry crusts shaped by environments unlike our own, creating behaviours that appear mysterious only because they are new. The lesson was not one of alarm, but of humility awareness that the galaxy holds more modes of being than we have yet imagined. Traveller, you are not lost in space, you are part of it. As November progressed, the object's electromagnetic trail thinned into the background plasma. The rhythm softened, the pulses stretched, the wake dissolved. But even in fading, Atlas continued to teach. It showed that activity can be delicate, influence can be subtle, and discovery can unfold as quietly as dusk settling over an observatory dome. And in that quiet, scientists felt something beyond measurement, a sense that they had not simply observed a visitor, but shared a moment with it. A moment where motion, magnetism and light aligned in a soft choreography few expected. Tonight, the universe whispers again. As 3i Atlas drifted farther into the heliosphere, its light began to soften, but its presence remained strangely steady. Even as photons faded and temperatures fell, the object's reflective profile lingered above predictions. Astronomers expected cooling, dimming silence, yet the curve held a faint upward bend, as though something inside the nucleus continued to breathe out gentle heat. Some phenomena do not resist darkness, they simply take longer to join it. Spectral lines added a quiet complexity. Water vapour remained detectable well beyond the point when most comets fall dormant. Carbon dioxide still appeared in thin pulses, and faint traces of ammonia moved with the gas like echoes from deeper layers. These were not signs of turbulence, only continuity, the last murmurs of volatiles escaping through pores etched over eons. In cold space, persistence is its own form of luminosity. rotation studies revealed a familiar rhythm. The 8.6-hour cycle held steady its brightness oscillations, returning with the calm of a pendulum that never learned to rush. Each rise and fall traced the slow turning of a fractured crust, exposing one vent after another to the fading warmth of the sun. Scientists described the pattern as a breathing curve, not mechanical, not chaotic, simply present. Silence often hides in repetition. The coma surrounding the nucleus grew thinner, but its shape remained smooth. No dust appeared, no ragged edges broke from the halo. Instead, the gas dispersed evenly, forming a soft sphere that expanded with each passing hour. Hubble's ultraviolet images captured the geometry, a ghostly globe drifting outward, too faint to startle, too symmetrical to ignore. It felt like watching an ancient lantern dim without flickering. Sub-millimeter arrays detected subtle chemical shifts in the coma. Hydroxyl signatures weakened while faint lines belonging to silicate vapor began to rise. These transitions suggested that solar heating had reached deeper zones, uncovering mineral-rich layers formed under colder starlight long ago. The crust was thinning not through violence but through patience, revealing new strata the way geological cores reveal ages. Listener, even the smallest fragment can carry the memory of many worlds. Where the coma met the solar wind instruments recorded soft distortions, nothing like the sharp ripples earlier in the event, but gentle bends in the plasma flow. The object still shaped the space around it, albeit faintly, like a drifting ember altering the movement of smoke. For heliophysicists, it was another reminder that influence does not require intensity. Even weakness leaves patterns. Trajectory models soon showed a slight deviation consistent with gentle outgassing. It was not the unexpected acceleration of Oumuamua nor the chaotic jet seen in volatile comets. Instead, the drift aligned with the object's slow rotation, each vent pushing a little, each pulse nudging the object with a touch too small to perceive moment by moment. Over days, the shift accumulated like the soft persuasion of a tide. The cosmos often changes course quietly. Mid-infrared maps from JDST still detected hotspots across the surface. They were faint now remnants of earlier fractures, but they appeared in the same configuration as before, aligned along elongated zones that hinted at structural regularity. Whether these were bonds formed by cosmic rays or simple evolutionary scars, no one knew. The beauty of the pattern rested not in its explanation, but in the patience it required to see it at all. As the object receded, optical signatures weakened, leaving mostly infrared and radio bands to tell its story. Arrays in Chile and Hawaii recorded tiny fluctuations in gas emission periodic, and soft as if the nucleus were releasing its last reserves with care. These were not dramatic events. They were the small closures of a long geological breath. Some endings choose quiet instead of fading. Studies of the crust deepened in significance. Researchers noted that its resilience, the way it flexed, instead of shattering during perihelion, could hint at mechanical properties uncommon in local comets. Tholin-rich organics mixed with silicates and polymerized by radiation may have formed a material stronger than any ice found within the solar system. This strength allowed the object to survive what others could not. Endurance can be a kind of story. At conferences and observatories, scientists found themselves reflecting more than concluding. They spoke of interstellar chemistry shaped by unknown stars of radiation, sculpting matter into new forms of fragments traveling through the galaxy, carrying structures and signatures unlike anything Earth-born intuition can predict. Atlas had become less a puzzle and more a teacher, an object that revealed as much through what it withheld as through what it showed. One researcher described the experience as studying an echo. Another compared it to reading a book missing half its pages yet still understanding the tone. In these soft metaphors, astronomy found something it often forgets, that knowledge can be gentle and incompleteness can be peaceful. Not every detail must be named to be meaningful. As Atlas moved beyond the orbit of Mars, its brightness fell below the threshold of small telescopes. Amateur observers could no longer trace its path. Even medium arrays struggled to find its fading shape against the background dust of the Milky Way. Yet for the larger instruments, for the patient sensors of JWST and Solar Orbiter, The object remained a whisper, still audible in the cosmic quiet. Traveller the Universe remembers. Data historians and mission archivists began assembling the long record. It stretched from the first detection to the last radio pulse, from the perihelion shock to the fading coma. The archive did not offer a single narrative, it offered many layered, like the crust itself. Some stories spoke of chemistry, some of structure, some of silence. All of them carried wonder. As November moved into December, the object's signatures slipped toward background levels. Only the faintest infrared echoes remained too delicate to analyze deeply, too beautiful to ignore. Scientists knew the moment was passing, but they did not rush it. They observed slowly, reverently, allowing the last signals to arrive at their own pace. For the researchers who followed Atlas from its first anomaly to its final soft glow, the object's departure felt neither dramatic nor sorrowful. It was a natural ending, a fading traveller returning to the long quiet between stars. Tonight, the universe whispers again. When the first weeks of November arrived, the flow of new data began to slow, not because the story had ended, but because the instruments themselves were falling behind the object's fading light. Observatories that once updated hourly shifted to longer intervals, allowing the exhaustion of photons to speak at its own pace. 3i Atlas receded toward a region where sunlight thinned, where spectra grew faint and quiet, and where the limits of our instruments became part of the narrative. Some discoveries leave not with a conclusion, but with a soft retreat. Though the public saw silence inside laboratories, a different kind of activity unfolded. Scientists pored over calibration logs, recalculated error margins, and stitched together datasets captured at the threshold of glare near the sun. Their work moved slowly, like dust settling in a dark archive room. Every correction revealed a nuance, a shifted line here, a cooled region there, a fading hint of a chemical once bright. Even in absence, the object continued to reveal itself. A quiet debate grew around the consistency of the late-stage signals. Gas emissions weakened but did not vanish, forming thin waves that seemed to breathe in and out as the nucleus rotated. The rotation remained steady, 8.6 hours, like a heartbeat, still audible beneath layers of silence. These faint modulations became precious. They carried the last traces of how the crust, fractured yet intact, continued releasing the memory of deeper ice. Listener, some rhythms are meant not to explain but to accompany. In radio arrays across the world, astronomers compared low-frequency data to the magnetic pulses recorded earlier. The coherence had softened, stretched, and blurred into the background, yet it persisted enough to confirm a truth: 3i Atlas was still interacting faintly with the solar wind. Not strongly, not like a magnetized body, but gently shaping the plasma around it, with traces of ionized molecules drifting outward. Influence has many forms, and not all require strength. Trajectory teams monitored small deviations accumulating over days. Each shift matched the slow venting pattern, as if the object continued steering itself almost imperceptibly through its own chemistry. The motion was not willful. It was physical law expressed through quiet persistence. A push from water vapour here, a nudge from carbon dioxide there, all aligned with its rotation in a soft choreography older than any human witness. The cosmos rarely moves abruptly. It drifts. Scientists noticed something else. The object's spectral fingerprint evolved even as it dimmed. Early signatures dominated by hydroxyl and cyanogen gave way to deeper, rarer lines, methanol traces of complex organics and faint mineral vapours. These final readings suggested that sunlight was now touching material unseen earlier, layers formed in starless cold, preserved beneath radiation-scorched crusts. To analyse them was to read the closing sentences of a story begun in another system. Some researchers describe this phase as post-luminosity evolution, a quiet settling of the nucleus after its awakening at Perihelion. The internal heat from chemical reactions and delayed conduction still wandered through the crust, releasing gases through pores too fine to lift dust. This was outgassing in its gentlest form, so soft that many instruments barely registered it. Yet its existence hinted that interstellar objects may remain active far longer than once believed. Comparisons to comets in our solar system only deepened the sense of difference. Most bodies fade rapidly after perihelion, retreating into cold stillness within days or weeks. Atlas refused to follow that script. Its emissions lingered, its light retained a faint resilience, and its layered chemistry continued expressing complexity. It was as though the object carried a timeline within itself, one that unfolded slowly, indifferent to our expectations. Meanwhile, the scientific community wrestled with the tension between patience and curiosity. Preliminary findings circulated in private groups but remained withheld from broader publication. Some feared misinterpretation, others wanted more certainty. Yet the delay was not secrecy born of alarm, it was caution shaped by respect for ambiguity. Sensitive data gathered near the Sun often contains artifacts. Rigorous scrutiny requires time. In science, restraint is also a form of honesty. Amid the discussions, a gentle question rose: how do we study an object that reveals itself only in fragments? The answer arrived not through equations, but through perspective. Atlas did not need to be fully understood to be meaningful. Its behaviour, persistent, layered, serene, expanded the definition of what interstellar matter can be. Even unanswered questions nourished understanding. The final spectroscopic sessions in early November carried a tone of farewell. Instruments focused on the faint halo shrinking behind the nucleus on the last whisper of hydroxyl, at ultraviolet wavelengths on the scattered hints of silicate vapour dissolving into cold. The object was becoming part of the background sky again, merging into the quiet sea of starlight and dust. Long journeys often end in places where attention cannot follow. Data analysts traced the last measurable shifts in the coma's size. It contracted smoothly, preserving symmetry, even in retreat, as though the dynamics shaping it preferred balance over disorder. This calm geometry became one of the most poetic signatures of Atlas, an interstellar body that behaved differently yet gently across every stage of its solar encounter. In conference rooms, researchers debated what, if anything, the object had taught us definitively. Some pointed to the dustless coma as the key insight. Others emphasized the layered crust. A few highlighted the rhythmic plasma interactions. Yet beneath all arguments sat a shared acceptance. Atlas was a messenger from environments we have never seen, carrying conditions we have not yet learned to model. Its very existence expanded the boundary of the familiar. As its signal drifted below detection thresholds, many astronomers found themselves reflecting on how quietly the event had evolved. No catastrophic breakup, no spectacular fragmentation, just a slow release of ancient ice, a faint shaping of plasma, a gentle redirection of its own path. The beauty of the encounter rested not in drama, but in nuance. Traveller, you're not lost in space, you are part of it. By the time November reached its end, 3 Atlas had become a whisper on the edge of instrumentation, a fading trace returning to the deeper dark. But what it left behind, layered data, soft anomalies, and moments of wonder remained. Its presence reminded those who watched that the galaxy is full of travellers older than memory, shaped by stars we will never see, carrying stories written in chemistry, silence and light. Tonight the universe whispers again. As November crossed into its final days, the Frithiossium Atlas no longer appeared as a vivid presence in the sky. It faded into a soft fragment of reflected sunlight, drifting beyond the reach of the most telescopes, yet still holding a place in the data streams of larger instruments. Even as its glow weakened, its story did not close. Some objects fade physically long before their lessons do, leaving behind quiet trails through memory and mathematics. Atlas had entered that gentle after state where observation becomes reflection. Researchers who had followed every flare and anomaly now found themselves studying the object through its echoes. The direct signals waned, but the models continued breathing with the data they fed on. Temperature curves flattened. Gas production trended downward but did not collapse. Every graph seemed to dim with dignity, like the ending of a long nocturne rather than the extinguishing of a flame. Not all departures are abrupt. Some are simple returns to shadow. As telemetry trickled in from Solar Orbiter and JWST, a final mosaic of insights began to form. The dustless coma, the rhythmic outgassing, the layered crust, all of it converged into a portrait of an object shaped not by a single environment, but by many. Atlas felt less like a visitor and more like a narrative of motion through multiple eras of cosmic weathering. The galaxy carves its stories into matter, not pages. One of the most striking realizations concerned resilience. Against expectations, the object had survived its encounter with the Sun without fragmenting. Most icy bodies endure perihelion, as a test shedding layers violently or breaking apart entirely. Atlas instead chose endurance. It flexed, vented, and continued its path with a slow steadiness that suggested mechanical strength born from ancient processes rather than sudden design. Silence can protect as well as conceal. The concept of interstellar evolution returned in late-stage discussions. If dustless radiation-hardened crusts like Atlas are common among long-wandering bodies, then our understanding of interstellar matter must expand beyond simple cometary analogies. These travelers may shift chemistry as they age, polymerizing organics on their surfaces, sealing volatiles beneath dark layers, and developing unique signatures when warmed by unfamiliar stars. The object became a reminder that age in space is more than time, it is transformation. When archives from the Atacama Large Millimeter Array were reprocessed, a new detail emerged. During the week after perihelion, faint periodic spikes appeared in the water vapor emission lines. These spikes were subtle, almost lost in noise, but they matched the rotation cycle perfectly. They suggested a vent that opened and closed with each turn like a heartbeat, expressed through vapor instead of sound. Listener. The universe often speaks rhythmically, even when it uses no voice. In the quiet of evening observatories, researchers revisited the earliest frames from SOHO and stereo. They found themselves lingering not on anomalies, but on the imagery, the small, elongated glow curving near the sun, the filament tail holding shape, the smooth halo expanding outward. These visuals captured across wavelengths told the emotional story the graphs could not. They were reminders that science is not only analysis, it is witnessing. As data synthesis matured, some scientists proposed that Atlas might represent a middle-stage interstellar body caught between the volatile youth of a fresh escapee and the hardened inertness of an ancient relic. Its balanced emission, controlled responses to heat, and layered crust suggested an object shaped over millions of years, neither raw nor fossilized. A moment of cosmic adolescence preserved in orbit. This interpretation reframed earlier debates. The perihelion brightening was not a warning, nor a coded signal, nor a failure of physics. It was a threshold event, a natural crossing into a new equilibrium after internal structures met sunlight more deeply than before. The brightening, the plume, the gentle thrust, all were consequences of a body adjusting to warmth after an age of cold. Change does not always roar. Sometimes it exhales. As December approached, the data streams narrowed to thin threads. JRWST caught the final reliable spectra showing the inner coma cooling into near uniformity. Solar Orbiter recorded the last coherent plasma ripple aligning with the object's path. These final signatures resembled a closing cadence in a long composition, subtle but complete. The universe often ends its songs without applause. Scientists preparing long-term models noted that Atlas would soon cross the region where sunlight no longer meaningfully shapes its chemistry. Beyond that boundary, it would return to interstellar quiet, carrying scars of its solar encounter sealed beneath cooling crust and drifting molecules. The next star to meet it, if any, would inherit a version of this object changed by our Sun, just as we inherited a version changed by another. At the final briefing of the season, one researcher described Atlas as a bridge between eras. Another called it a record of patience. These were not dramatic conclusions, but reflections shaped by nights spent watching faint lines on screens, listening to the hum of instruments, and letting the presence of a distant traveller settle into thought. Traveller, even in silence, companionship exists among the stars, and so the story of 3i Atlas reached its soft closure. Not through disappearance, but through dispersal. Not through answers, but through alignment of data, of understanding of awe. The object continued its outward motion, no longer bright, no longer surprising, yet still profoundly real in the imaginations it touched. Tonight, the universe whispers again. As 3 Atlas slipped past the reach of the last instruments, it no longer appeared as an object, but as a fading presence woven into the dark. The final spectra carried only thin signatures of water and carbon, scattered like the final notes of a long-drifting song. There were no more pulses, no more coherent ripples, only the slow dissolving of a light into interplanetary silence. Some endings do not break. They simply become quiet. In the laboratories that had watched every fluctuation, the tone shifted from urgency to reflection. Charts stabilized into soft slopes. Uncertainties narrowed. The remaining data converged into a portrait both humble and vast. Atlas was no longer defined by what it did near the sun, but by what it revealed about matter shaped under alien conditions. Its behaviour, dustless, layered, reactive, became a reminder that the familiar rules are only local customs of our own system. The final analyses approached the mystery gently. No grand claim emerged, no singular interpretation prevailed. Instead, the object was understood as something old, something shaped by places long vanished, responding briefly to warmth it had never known. Its perihelion brightening, once startling, now appeared as a natural expression of internal structure, chemistry and time. Even ambiguity can be instructive when met with patience. By late November, observatories completed their logs and archived the data with a kind of reverence. Beyond Mars, Atlas drifted toward regions where sunlight weakens and memory fades into cold. It carried with it the subtle scars of its passage through our sky fractures, pores, and a faint residue of heat marks of a world that had brushed briefly against ours before returning to the long starless road between systems. In its passing, a quiet realization settled across the scientific community. Significance is not measured by spectacle. Atlas did not shatter or ignite. It did not declare its nature. Yet it expanded perception, stretched the boundaries of assumption, and made the universe feel larger by refusing to fit neatly within our models. Wonder does not require noise. Sometimes it grows best in unanswered questions. As the last traces dissolved into the solar wind, the sky returned to its usual stillness. But a small piece of that stillness had changed. The encounter left a shift in perspective, a recognition that even the smallest visitor can carry the memory of distant stars, and that our place in the cosmos is shaped as much by what we see as by what refuses to be fully known. Tonight the universe keeps its silence. Traveller. We have reached the edge of tonight's story, where Three-Eye Atlas fades into the cold distance, and the questions it awakens settle into a quieter kind of light. Its passage carried no answers, only reminders that even a fragment born under another sun can change the rhythm of our own sky, and that mystery is not something to be solved, but something to share. What drifts between the stars is never finished. The universe continues to breathe, to shape, to whisper in ways our instruments barely touch. And in watching this interstellar wanderer flare dim and slip away, we were granted a small truth. Wonder is not a destination. It is a companion, a presence that follows us long after the data ends. As the object recedes beyond Mars, as the telemetry quiets, and the final light curves smooth into memory, let yourself rest in the knowledge that you are here witnessing a moment carved from cosmic time, brief and fragile yet real. The night will hold the rest. Rest well, traveller. Stay curious. The universe will keep watch.